Hello, I'm Wansi from University Putra Malaysia. Today I'm going to present my FYP final year projects with the title of Sugar Recovery from Bakery Waste via Subcritical Water Hydrolysis. And this interesting topic is prepared by my supervisor, Dr. Siti Mazlina. And I'm feeling great that to have this opportunity to have these topics as my FYP final year projects. So now let's start my presentations. As we know, the bakery industry is one of the greatest industry in food production. In Malaysia, the authority encounter challenges in treating and solving the problem of food waste. Uncontrolled amount of bakery waste may lead to environmental issues such as greenhouse effects. In fact, bakery waste is carbohydrate-rich food product, and it can be hydrolyzed and recovered to obtain its sugar to alleviate environmental issues. Bakery waste is abundant. Based on one of the bakery industry, it mentioned that it's approximate 10 to 20% of bakery waste can be generated from daily production. So, bakery waste is potential for sugar recovery and thus reduce the waste disposal. To obtain the sugar back from the bakery waste, acid hydrolysis and enzyme hydrolysis can be used. However, for acid hydrolysis, it may cause degradations of monosaccharide with sequential formation of toxic substances because it involves chemical substances. While for enzyme hydrolysis, it may incur high expenses and also time-consuming. Hence, a clean, quick, and environmental-friendly hydrolysis is needed, and this problem can be solved by subcritical water hydrolysis. And this hydrolysis is operate at 100 degrees Celsius to 374 degrees Celsius below the critical pressure of 213 atmospheric pressure, which is also known as 22 megapascal. The objective of my study are to evaluate the sugar recovery from the bakery waste by using subcritical water hydrolysis, and also to study the effects of the process parameters such as temperature, time, and solid to water ratio, which is a solid loading, on the recovery of the sugar using subcritical water hydrolysis. The pictures here show the sample of my FYP projects, which is the leftover chocolate cakes. So for my study, the first one I will study about the proximate and bacteriological analysis, and followed by the pH measurement using the pH meter, and also the total sugar content and reducing sugar content using the spectrophotometer, and followed by the analysis of the optimization using the Minitab software, and also the sugar profile analysis I will using HPLC method. And I also study about the Fourier transform infrared FTIR spectroscopy. This is to determine the functional groups that present in my chocolate cake samples. Then finally, I will have the scanning electron microscopy SEM to observe the surface changes before and after hydrolysis treatment. So for the result and discussion of proximate and bacteriological analysis, the table here has shown that carbohydrate have recorded the highest concentration as compared to other components, which is 47.4 gram per 100 gram, and have the high potential for sugar recovery. And its mole have recorded less than 100 CPU per gram, which show that is safe. For pH measurement, the leftover chocolate cake show a decreasing trend at the process temperature from 160 degrees Celsius to 200 degrees Celsius at 50 minutes of process time with 50% of solid loading. And the decreasing trend could be due to the molecular vibrations increase with the temperature, which result in water ionization, and more hydrogen ion is produced. For total sugar and reducing sugar content at solid loading of 50%, we can show that based on the contour plot, it shows the increasing trend of the sugar yield when the process temperature increase from 100 degrees Celsius to 160 degrees Celsius to 200 degrees Celsius, and the processing time increased from 5 minutes to 15 minutes. And here show the legend, we can observe the concentration of the sugar. For the analysis, for the optimization, this is the suggested value given by the Minitab software, and this is the experimental result from me. And the difference between both results is here, which means is at the acceptable difference of percentage. For the sugar profile analysis, I have using the HPLC method to determine the reducing sugar content in my chocolate cake samples. And this table has shown that the content of my chocolate cake samples, and here show the result of my components in my chocolate cake sample, include the sucrose content. The peak here show the presence of hydroxyl group, and here show the presence of aldehyde and also ketone groups, and both of these is the functional group of the sugar, and these have double confirmed that the presence of the sugar in the chocolate cake sample. For SEM, before treatment, the surface of the chocolate cake sample is still moved. After the process temperature reaching 160 degrees Celsius, the globules start form and the surface become rougher. After reaching 180 degrees Celsius, the surface have breadth and more sugar are obtained. When reaching 200 degrees Celsius of processing time, more and more sugar are obtained because the surface are nearly totally bread. So in conclusion, to obtain the higher use of sugar content of the bakery waste, the desired process temperature is 200 degrees Celsius, the process time is 15 minutes, and solid loading is 50%. So the objective which I mentioned previously have been all achieved. So for recommendation, parameters can be increased to a wider range, for example 100 degrees Celsius to 300 degrees Celsius, and more other samples can be used for investigate rather than chocolate cake sample, and also the hydrolysis method, other hydrolysis method, for example supercritical water hydrolysis, to find the best method for sugar recovery. That's all of my presentation. Thank you for lending ears.